In example 5, we're asked to find all trig values if a point on the terminal side is -5, -12. We are definitely not on the unit circle here. We'll find that out for sure soon, but I want you just to know that -5, -12 is way outside of the unit circle. Let's plot it though and see what it looks like. So this point, -5, -12, which we're going to approximate here. Maybe that's right here. If this is -5 and that's -12, that would work out sort of. Then this angle here, the terminal side of the angle, is going to lie right on that point. Okay, and that point is right on the terminal side. There's a few different ways to solve this one or find these trigonometric ratios, so I'll show you both real quick. Some folks are going to want to draw a reference triangle here. It's important that you draw that with the right angle here next to the x-axis, and then also this is going to be our reference angle. Okay, and this is our reference triangle, and we could figure out this angle, but I'm not sure if we'll really have to. This side over here is -12. That's the y direction. So if we look only at this triangle, we want to try and find out this radius here, because we know that x is -5 and y is -12. So what we're going to do then is we're going to either use the Pythagorean theorem, or some of you may know this triple, 5, 12, 13 would work here. So if you took 5 squared, or -5 quantity squared, and added that to -12 quantity squared, you'd get 169, and then the square root of that is totally 13. So if you're not familiar with those triples, you can still use the Pythagorean theorem. For this angle right here, you could set up all of your trig ratios. You could say that opposite over hypotenuse would be -12 over 13, and that would work. If you use your knowledge of the sign being y over r, you can just go back to these three values right here and then substitute what you need. So it becomes also very easy. We've got -12 over 13. So you see, you can use the opposite and hypotenuse, but it's a really nice idea to transition to these values and understand these trig functions on the coordinate plane. That method also tends to break down if you forget that this is the angle you're supposed to use. Some folks will try to use this angle. The sine of this angle is -5 over -12, and that would get you, that would be -5 over 13, and that wouldn't be the right answer. So this becomes very, very easy if you can utilize x, y, and r. Sine is y over r, cosecant is r over y. We'll just use the reciprocal here. That's -13 over 12. The cosine is x over r. It's still adjacent over hypotenuse, and you can do that here. So you could say the adjacent side of this angle is -5, and then the hypotenuse is 13, or if you found your x, y, and your r, -5 over 13 would work, and it's exactly the same thing. Exactly the same thing. The secant then will be r over x, so that's -13 over 5. The tangent is y over x, so when we set this up, we're going to go -12 over -5, and we want to simplify this. Negative divided by a negative is a positive, so this will be positive 12/5, 12 over 5. The cotangent is the reciprocal of the tangent, and so we need to either just flip this one here, use the reciprocal there, or you can set it up x over y, -5 over -12. The negatives together, negative divided by negative, would be a positive, and you'd wind up with the reciprocal of 12 over 5, which would be 5 over 12, any which way that you'd like to do that.